Hi everybody, this video is about Taylor series, simple explanation for Taylor series. I'm gonna try to keep this board as far away from me as possible so that I can cover the entire board. So, then I was looking for application of Taylor series on the internet. The first article obviously was from Wikipedia, and it had extensive, rigorous mathematical explanation. And obviously, this concept of Taylor series is mathematically quite deep, where a mathematician would use it to get an approximate value for a function at some given point. But for application basis, it's not that deep and it's not that hard. So I'm making this video to give a simple example of how and where Taylor series can be used. Now this is the question. If fx is a complicated function, if a given function is fx, and if it's a complicated function, and you were asked to find the value of fx at x given as another complicated number 1.2536, then you should use Taylor series to get that. Now sometimes for complicated functions, or even for simple functions, the values might not be that simple. Like if fx, even if fx is a squared function like x squared, and you are supposed to find out the value of this function at x equals 1.2536, then it's gonna be pretty hard. So you can use this Taylor series to approximate that value. Now, in order to do that, you need three things. So this is the solution. Now you need three different things. I'm going to go over them one after the other. First, fx at x equals something simpler than 1.2536. So you need x at something simpler than this big number. In my example of fx equals x squared, the simple number would be 1, because you know the answer to 1 squared, which is obviously 1. So that's first thing that you need, a simple number. I'm going to denote this by s number, s hash from now on. The second thing that you need is the derivative of that function. And the f dash x is the first derivative, f double dash x is the second derivative, and the third derivative, and so on. Now you need you don't just need the function of derivatives of the big function. You just don't need in terms of x. You need these derivatives at the simple number that you just chose. So if you chose x equals 1 as the simple number, the s hash, then you need f dash at s hash, f double dash at s hash, and f triple dash at s hash. And you keep going till, depending on the kind of accuracy you want. So that's the second thing. Then the third thing that you need is the difference between the given number and the chosen number, right? The chosen number is the s hash, the simple number, and wait, no, the given number, I'm sorry, the given number is the x equals 1, the s number, the simple number, and the chosen number is 1.2536, or the other way around. Doesn't really matter. There are two numbers and you need the difference. So if in our example, x equals 1.2536 and the other is 1, so you need the difference, which is 0.2536. That's what matters here. Now this is Taylor series. To get the value of a function, which is maybe x squared at this number, 1.2536, what you can do is, you can say, you can expand this in this manner. You can say f at 1.2536 can be written as f at simple number plus the difference, which in our case will be 1 plus 0.2536. And that, using the expansion of Taylor series, can be written as f at simple number, which is 1 in our case, plus f dash at simple number, which is the first derivative of the function x squared at the simple number, times the difference, plus f double dash at the simple number times difference squared. And then you keep going, and I'm just gonna say out loud the third term so that you know what it is, because I didn't have space, I couldn't write it down. The third term would be f triple dash at simple number times difference cubed, and fourth term will be f 4 dashes, the fourth derivative of the function, that simple number, times difference to the power 4. So in our example again, the expansion would be f at x equals 1 plus f dash at x equals 1 times the difference, which is 0.2536, plus f double dash at x equals 1 times 0.2536 squared. Now, you cannot go f triple dash for this function because f1 dash will be 2x, f double dash will be 2 for x squared, and f triple dash will just be 0. So no matter how many terms you add, you're not going to get anything. What this means is you have reached the actual answer, the definitive answer for this function at this given value. Yeah, this is the simple explanation I'm going to make. I hope I can cover the entire board. I think I can, I think I have. And yeah, this is an explanation for Taylor series that I use every single time I revisit this topic, because books are really, really complicated, and they somehow like to make things complicated. But this explanation really helps me every single time, so I hope it does help you guys too, and yeah, thank you.